Alright, welcome to a little help video on the elimination method when we are solving simultaneous equations. What I've got here are a few questions from exercise 2J, question 4, and that will hopefully make a little bit clearer the method that I use. Watch through them, try and follow along if you can. If you think you're getting the hang of it, maybe do the last one or two before I do them, but otherwise I'll get stuck in and we'll see how we go. So I've got my two simultaneous equations here. I'm just going to try and zoom in a little bit. There we go. And let's see how I go about solving these. So I want to try and do elimination. Now at the moment, the coefficient of x in the first equation is 4, but in the second equation it's 3. And the same with y. In the first equation it's 1, in the other equation it's negative 2. What I mean the same with y is the coefficients aren't the same size. And for the elimination method to work, we need the coefficients of at least one of the variables to be the same size. I'll do this one twice. I'll do it once where I make the y variables have the same magnitude coefficient, and another one where I make the x variables have the same. And we'll see we get to the same answer. The reason I would probably choose the y variable here is because if I could make this a positive 2y, well, when I add the equations together, the y's would cancel out. So I'm going to go ahead and do that now. So I'm just going to multiply that equation. I'm going to label them. There's 1 and 2, just so that it's easy for people to follow along what I'm doing. And I'm going to multiply equation 1 by 2. That's going to give me 8x plus 2y equals negative 16. So each term just got multiplied by 2. I'm leaving the second equation alone, so I'm just going to say it's still equivalent to 6x minus 2y equals negative 17. Now the beauty here is if I add these equations, those y values are going to cancel. Did I say 6x when it's a 3 there? Look at me getting carried away. 3x minus 2y equals negative 17. So now I'm going to add them. 8x plus 3x is 11x. On the other side, 2y minus 2y, that's equal to 0. So the y's have been eliminated, hence the name elimination method. Negative 16, add negative 17, so take away another 17. That's going to give me negative 33. Now I can just divide each side of that by 3, and by 11, and I'm going to end up with x equals negative 3. You can see where I was jumping ahead there. I can now go ahead and solve for y. I'm going to let x equal negative 3 in the first equation. So I'm going to have 4 times negative 3 plus y equals negative 8. Negative 12 plus y equals negative 8. And I'll do my last substitution. Add 12 to each side. I'm going to get y is equal to 4. It's always good to check your values and to write a nice little answer. I'm just going to insert a little bit more space there. How would I check it? 4 and negative 3. That's 4 for y and negative 3 for x. If I put them into the other equation, 3 negative 3s and negative 9. Negative 2 by 4 is negative 8. Negative 9, take away another 8, negative 17. I feel like I've got the right answer. And I'm just going to write my little answer here. The simultaneous solution is negative 3, 4. Now I promise you I'd do it a different way. I don't want to make a liar out of myself, so let's go ahead and do that now. Starting with the same two equations, I'll even write them out again just to make sure we're okay. 4x plus y equals negative 8. And the second equation there, 3x take 2y equals negative 17. What I'm trying to do, I'm trying to get the coefficients of x to be the same. Well, I know that 3 and 4 both go into 12, so I'm going to multiply this first equation by 3. What's that going to give me? It's going to give me 12x plus 3y equals negative 24. And if I multiply the bottom equation by 4, every term gets multiplied by 4, I'm going to get 12 minus 8y equals negative 68. Okay, I've got my two equations there. If I do the top one minus the bottom one, 12x minus 12x, the x's are going to be eliminated. So this time I'm going to do subtraction. So I'm going to have talked about that. That'll eliminate 3y minus negative 8. So when you take away a negative, you're adding. So 3 plus 8 will give me 11y altogether. Negative 24 minus negative So add 68, that's going to be 44. Dividing by 11, I'm going to get y is equal to 4. Substitute this into one of the other equations and we're home. I'm going to substitute it into equation 2 this time. Let y equal 4 in equation 2. Therefore, 3x minus 2 times 4 equals negative 17. 3x minus 8 equals negative 17. Add 8 to each side. 3x equals negative 9. And dividing by 3, x equals negative 3. And I'd write a similar statement to the one we had there, and we'll be okay. So the real key, you want to get the coefficients of one of the variables the same. How do I go about doing that? Well, I multiply one, as I did in the first case, or both equations, until I've got the coefficients the same. I might do one more here for us. Here we've got negative x plus 4y equals 2. 3x minus 8y equals negative 2. Again, you could do it either way. Get the x's the same or the y's the same. I'm going to get the y's the same. Maybe you could try it again and get the x's the same and see if it's going to work for you. Multiplying the top equation by 2, I will obtain negative 2x plus 8y equals 4. Leaving the bottom one alone, I've got 3x minus 8y equals negative 2. You can see I've got an 8y and a negative 8y. The signs are different, so if I add them together, they'll be eliminated. So I'm going to do addition again this time. Negative 2 plus 3 is positive 1, so I'm just going to be left with x. Look at that. And 4 minus 2 is 2. It took me to the answer for x straight away. That's nice. Now I'm going to say let x equal 2 in either of the equations. I'll choose equation 1. Therefore, negative 2 plus 4y equals 2. Add 2 to each side. I've got 4y equals 4. Y equals 1. So the simultaneous solution is 2, 1. Does it work for the other one? 6 minus 8, negative 2. That works pretty well as well. Hopefully that will work for you. I will see you in the next video. Thanks for watching. Cheers.